So here we are going to have three breakers. First one here, okay, so these are the three supplies that we are connecting to the automatic changeover switch. And so we have here supply 1, here supply 2, and then here supply 3. Okay, so these are our main switches that control each of the input supplies. The next thing I'm going to show is the contactor. So we have this 1, 2, 3, then 4. 1, 2, 3, and then 4. Then here also 1, 2, 3, and then 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Okay, so this 1, 2, 3 are our main switches. So main switch or main breaker. Then here, our contactors. So the contactors are actually represented with the terminals. And so on each contactor, there are 1, 2, 3, and then 4 terminals for input. And then 1, 2, 3, 4 terminals for output. The terminals are actually labeled. The labeling is L1 with output T1, L2 with output T2, L3 with output T3. And then another one that is meant for auxiliary contact is labeled 13 and then 14. But in this video, we are going to make use of only 2 of these terminals out of the 4 terminals. Now, the labeling L1, T1, L2, T2 does not really matter when using the contactors. All that matters is that one side will take the input and then the other side will take the output. In this video, my L1 is here and then my T1 is here. L2 is here and then T2 is here. Okay. And I have decided to turn the contactors that way to make it convenient for the connections that I'm going to do, especially the connections to the coils on the contactors. Okay, the next connection we are going to do, we are going to link each of these supply sources to their corresponding contactors. So this will be contactor 1 for supply 1, contactor 2 for supply 2, contactor 3 for supply 3. So I said already that I'm using just 2 terminals out of 4. So here, I'll connect live from the output of this main switch to terminal 1, like this. And then I will connect neutral from the output of this main switch to terminal 2, like this. And then the same thing happens to the second contactor. And then the same thing to the first contactor. And so it simply means that we are not using these 2 other terminals at all in our connections. All these contacts are normally opened. All right. Then now we are left with how to interconnect the output of these three contactors to constantly give us supply output at the consumer unit from any of these supply sources. All right, so this will represent our consumer units. So the main lines that will connect from this arrangement to this consumer unit will have live connected here and then neutral connected here. So at the output side of the contactors, we would have to link the three input supplies and then take it to the consumer unit like this. We take L1 from here to L1 here. It could be T1 depending on how you turn your contactors. But in this particular video, this is L1 for contactor 3, and that connects to L1 for contactor 2. And then we'll take another loop from L1 on contactor 2 here to L1 on contactor 1. So here we'll take a loop to contactor 1. Okay. So in effect, this is the input side of the contactors, and these are the output sides of the contactors. So here, the live output from this contactor is taken to the live output of the next contactor, and then looped to the live output of the other contactor. Okay. And then we do same to the neutral lines. So here, remember we are using L2 for our neutral line. So L2 moves from here to L2 here. And then we take a loop from the same point to L2 here. And then our next connection will be to the consumer unit. Okay. So we take live from here. From here. Okay. So our consumer unit, CU, our contactors, 1, 2, 3 contactors, our main switches or main breakers, 1, 2, 3, and then these cables are coming from our various supplies. So because this is a single phase system, we are using only two lines, that's live and neutral. And so we have live and neutral taken from the output terminals of the main breakers to T1 and T2 as it is in this video. And then the same thing to all the contactors. Then at the output side of the contactors, we had to connect L1 of contactor 3 to L1 of contactor 2 and then to L1 of contactor 1. Then we did the same thing for neutral, L2 from contactor 3 to L2 on contactor 2, and then from L2 on contactor 2 to L2 on contactor 1. Then the same loop is what will feed to our consumer unit. So this is how it works. All these main switches must be closed. They must always be closed. And then, depending on which of these contactors will activate, it automatically sends supply through these lines to the consumer unit. So let's say contactor 1 is activated and then all these contacts closed. They will have live from here flowing through the contacts to the consumer unit. The same thing will happen to neutral. Now, if this is opened and this one is closed, the power that is transferred from here will still go to the consumer unit. And the same thing applies to this third contactor. Now, you can see that the outputs are bridged and all these supplies are not from the same phase. These are three different supply sources. And so it is very disastrous to have all these phases come together. So then it means that one important aspect of this arrangement is that we have to do it in a way that at every time, only one of these contactors should close, because these mains must always be on In case all of these three supplies are available at the same time, one contactor must be set to operate before the others for smooth operation and for safety. And so how those arrangements are made and how the connections are done will be shown in the control wiring and also in the practical wiring. Thanks very much for watching. And if you like what you just watched, kindly click on the like button, share with your friends, and subscribe to stay connected. Thank you very much again. See you in the next video.